off the fire detection system. It goes back to working. That is basically how the kitty and the Fenwall continuous loops work. But in today's world, they came up with an even better system that is referred to as a cistern-donner system. And basically, the cistern-donner is if we take a tube, a big long stainless steel tube, and we seal both ends of it and put a pressurized gas inside of it, then as we heat up that gas, what happens to the pressure in there? It increases. So we'll take that trapped gas and put it into a housing that has a diaphragm in there. That diaphragm will turn on and off a switch. As that pressure increases inside of that tube, the diaphragm pushes against the switch, closes the switch, turns on the fire detection system. All right? So it tells the pilot that there's a fire in the right engine or the left engine or wherever. That basically, then he'll trigger the fire extinguishing, put the fire out. As it cools down, the gas cools down, contracts back, switch turns off. Every one of these units will tell you when there is a fire and when the fire goes away. All right? The fireboards work, they're going to have power to them. We have several different types of fire extinguishing systems on the little board. We have both the kitty and the Fenwall continuous loops are on the small board. You can see the two loops. You can check them out. We also have the bimetallic switches, which is on the right side. They have basically two little pieces of metal that stick up. They are both kind of curved. Some of them will have a longer piece of metal. How many of you guys have ever done take your belt trick, take your belt off, fold it in half? If you push the belt together, what happens to the two halves?
Makes a gap.
Makes a gap.
Snap
and
it.
then as you expand them out,
Snaps.
yeah, that gap comes together. They have a switch inside of them that works exactly the same way. The outside housing is stainless steel. It's put in the areas of the engine where there may be a fire. If there is a fire, the outside portion of it, as it heats up, what happens to the length of stainless steel when you heat it up?
Increases.
It increases. Inside of there, there's a deal like a belt with a switch on the top and a switch on the bottom, and as that unit expands, those points come together, closer together, until eventually at a certain temperature, they touch. You can actually adjust the inner portion of it, the pulling on the belt, to a specific length, so you can actually heat them up to a certain temperature, and by adjusting the inside piece, you can adjust when the switches turn on and turn off. So they're actually adjustable. As they heat up, it makes contact, tells the pilot there's a fire. Okay? The trouble with those is the fire has to be right there where the switch is. With the continuous loops, you can run them all over through the engine compartment, and it provides a very large area of fire detection. In most of today's engines, I mean, if you stop and think, on most jet engines, what parts of the engine can catch on fire? How many of you guys have already had power plants? All right, a couple of you. What parts of the engine have the potential for fire? How about the compressor? Can the compressor catch on fire? No. What's up there? Air. It's just purely airflow through there. The only thing that may come close to it would be the oil on the bearings, but that's it. I mean, it's really not likely. Where are we most likely to have a fire? In the turbine section, or where the fuel and the oil is, right? So if we run our continuous loop through those areas and there's a fire, works good. Or if we have a switch system, we would have to put a bunch of individual switches in the area where it's most likely to catch on fire. Smaller engines like the PT6s, Pratt & Whitney.
Penis. Penis. Penis.
All right. On this particular engine, the air comes in here. This is your compressor section from here to here. You notice they actually sectioned this off with stainless steel bulkheads out to the engine cowling. This area here, is it likely to catch on fire? No. No, not at all. This area, we have the oil tank, we have the fuel, the carburetor, basically same difference. It's the fuel metering unit, oil system, ignition system. We have potential back here for fire, don't we?
Yeah.
If there is a fire back here, what direction does heat go?
Up.
Up. So if you look, basically sitting right here, this is the mounting plate for it. There's actually one of these units mounted right there. All right? So if they mount it right here, and there's a fire back here, will this sense it?
Yeah.
Yeah. All right? How about up here? Fuel nozzles, 6,000 degree heat inside of here. From here to here, you betcha. Mounted right here, another fire detection unit. All right? They're going to put right here. There's another one that mounts here. So 3 of them, we have pretty much complete fire detection system in here. Now, normal in flight, there's enough airflow through here, it'll keep that from going off. But if there is actually a fire, it will give you a fire warning system. If there is a fire on this engine, what's the best way to put it out? Yeah, turn off whatever's feeding it. So, what's that? Well, it's kind of hard to do on an airplane in flight, isn't it? I mean, there's lots of air there. Literally, back in World War II, the easiest way to put out a fire if you didn't have a fire extinguishing system was try to give the fire too much air. So in other words, they would try to fly the aircraft fast enough to blow the fire out. Worked sometimes, sometimes it didn't. Sometimes you just got used to seeing them crash a little quicker. Okay? But anyway, our detection systems work much better. They basically have a chemical fire extinguishing agent that is maintained inside of these tanks. This was a twin engine airplane, so we have 2 fire extinguishing systems, a left and a right, with a left engine and a right engine. But the thing is too, if you look at how they're plumbed, let's see, the one from the right side, there's a little valve down here that you can open up. These are pressurized to about 500 psi with the fire extinguishing agent in here. If you open a 1-inch diameter hole in this, you punch a 1-inch diameter hole, that 500 psi of gas is going to come sailing out this tube, through this tube, and go to the engine compartment and put out the fire. Should. If it doesn't, you'll notice that each one of these units has 2 tubes coming out and 2 triggering units to fire them. So if that doesn't work, then we could fire this one on this side, and it would go right back to the fire, same fire on the same engine. So you literally have 2 chances to put it out if the first one don't work. Actually, in most engines, if there is a fire, they're going to have an indication here. So the first thing that they're going to do is pull the switch, all right? As soon as they do that, this is going to shut off all of the sources of fuel. What kind of sources of fuel do we have in a turbine or a jet or a reciprocating engine? Gas, hydraulic fluid, electrical, engine oil. Yep. 4 different things that could cause it. This shuts all of them off. It shuts off the fuel valves, so at the firewall, so it should shut off all the fuel going forward to the firewall. It shuts off all of the oil control valves, so it should basically stop all oil flow, hydraulic flow, and electricity to that engine.
So when you pull that switch, the plane basically start gliding. I mean, just turn off.
Well, how many engines do we have in this airplane? 2. Yeah. So hopefully it should fly on 1. Yeah. Well, if they can fix whatever's causing the fire, they'll start the engine back up. But if not, they'll fly on the 1. All right. It'll get them back to where they need to go. They may have to trim rudder and various other things. You'll learn more on flight controls next hour. But anyway, fire detection systems aren't elaborate. As a matter of fact, the more simple you can keep them, the more simple they are, and the better they work. Most of today's, probably the most preferred unit is a sister-on-donor unit in most of today's bigger airplanes. And it basically, as I said, is just a tube with a gas in it and behind the firewall, that's where they put the little pressure switch unit that when there's enough pressure closes the switch and turns the unit on. What kinds of problems could we have with a system like that? Sure, we could have a leak in the pressure tube. It could crack or something could wear through it. The tubes are made out of stainless steel, so they're not likely to, but what kind of things would...
Corrosion?
Yeah, or even wearing enough of a kink or wearing against the clamps could possibly damage them.
There's no way to tell that it has a hole
in the very first ones, no.
other than inspecting it?
Okay, other than inspecting it, and they did have a pressure test unit that measured the pressure in here. But once again, if something wears through it and we lose all our gas, is that system going to work? No. No, it's dead in the water. So, what they got the bright idea of is, you know what we can do? We can take that pressure tube and put it inside of another tube with pressure in it. If we heat that tube up, isn't all those gases still going to expand? But then what happens is if we wear through it and we wear a hole in the outside tube, it's going to leak the pressure out. That's going to give them a warning, but the inside tube that is actually sensing the fire still works. And it's going to take a while to wear through that. So it tells them the fire loop has a problem, but will it still work?
Yeah.
Yeah. So they can keep right on flying, fly to the next maintenance base and get it fixed that night. And of course the fix is that you're going to have to pull the loop out and change the loop. They send the loop back to the factory, they find the hole in it, weld it back shut, put the gas back in it, pressurize it back up, send it out again, and it's good to go. Made out of stainless steel, so it takes pretty good fire to hurt it. They're, repairable loops, and you can use them for a long period of time. So anyway, you guys can go ahead and